Let's understand our new topic, which is balancing the chemical equation. In previous class we discussed what is the chemical equation, what is the chemical reaction. Let's brief intro. A chemical reaction, chemical reaction is the process where some reactant react each other, and after the reactant we obtain the product. Like anything else, you see daily life, you even also create a chemical reaction when you use two product, they react each other and then become a new product. Like in milk you add salt, some we get a new product. So this is the also kind of reaction. You add some sugar on the milk, you get also. So this is an example of this. Okay, now what is the chemical equation before going to the balancing chemical equation? So a chemical equation, I see the chemical equation. For example, a lot of reactant and product are formed. Okay, so we see the reactant A plus reactant B plus reactant C plus reactant D and form the product E plus F plus G plus of H. For example, A is a sugar, B say water, example, C say for example again the milk, and D say the next reactant. Okay, anything else, and the product what we get is the depend on the reactant which we have. So some of the reactant are basically, and when we moved in the further classes we discuss the rate of the reaction. So in the rate of the reaction we know that the d of psi divided by dt, basically it is the higher level. In when we go to the 11th and then further undergraduate level, we see that the in the rate of the reaction extends. So basically the the product which is absorbed, the reactant which is absorbed is equal to the how many product it form, basically equal that. Okay, so in the class 10th we discuss the brief. Okay, now so we have four type of this. So now like the sugar, so the overall reaction say this: when we add some sugar in the water and then water and sugar mixture we add to the milk, and some kind of pressure we using the another reagent, to say the chili powder, anything else, then we obtain the new product. Say it is all are product. Okay, so instead of using like a we add, so for like a second chemical equation I am using the H2O. How they create, say hydrogen plus of oxygen, when they meet we get the overall reaction like this way. So they I read, so like in hydrogen plus of one O2 we get the H2. This is the overall reaction. Okay, so instead of using the long form we use simple symbols. For sugar, for I say A, for water say B, for milk say C, so D for reactant. So I'm using, instead of using the sugar, water, milk, then I indicate by using the this ABCD. Basically chemical equation is the indication of all the reactant and product which are involved in the reaction. Okay, now the main part is the balancing of chemical equation. The balancing, first question came in our mind is why we need to balance a chemical equation. Without balancing the work is already done. Yeah, good question. But we understand like in a chemical equation, like imagine a chemical equation of a two classes. Okay, the chemical equation is involved in this A and B, where B is the product in. So the all the chemical equation in this, the reactant part and the product part is this. So the all the product which is obtained is came from the reactant. And we not extra adding the reactant or the product, the all happen in the same way, like the reactants you convert into product. So in this case we can say that the number of like the number of reactant should be, because the product is formed from the reactant, should be the number of product. This is the overall conservation of atomic number of mass conservation, like the atomic number mass of neither create not destroyed, it's converted from one to another. So basically the all the reactant are converted into product. So number of reactant is number of product. So number of reactant is equal to the number of product, maybe. So that's why we need to balance the stoichiometric coefficient of all the reaction to achieve this law, like the basically it was this things, why we call this is the law, but for understanding, because this thing the all should be equal. So once again, since the reactant and product should match, should equal, so then okay, that's why we introduce the concept of balancing. Okay, I told you the stoichiometric coefficient. Stoichiometric coefficient, it means, for example, a chemical reaction is A plus of B gives the product C plus of D. So some amount of A is using and some amount of B is using, and some amount of C and some amount of D is obtained. To A to B, like 2 spoon of sugar in the water of 1 ml, 2 ml, then create the one whatever is the sweet product. Okay, so these A and B are and C and D are generally called stoichiometric coefficient. Okay, this is the overall stoichiometric coefficient. This is the overall. Okay, now we balance the chemical equation. So now we have, for example, a equation A and B and C and D. So how we balance the chemical equation? Can you think it again? Maybe we start from the higher value. Okay, for example, if in both case, in the reactant and the product, if a amount is high, so it also in the high. So if we match the amount in high and high on both sides, then automatically the lower part is also high, because some amount of B is add in the C and some amount of is the so the first step, if we add the both, if we from high we get, and then low, then low, then low. So think like if and first if we give the higher value, the first we, because of higher, so we find the higher amount of atoms in match together, and second the lower, the automatically the chain can convert the whole reaction into the balance. So step 1 is basically balance high element, and step 2 balance then low. Basically it balance our chemical reaction with these steps. Okay, so I use some chemical equation once again. Okay, so I use our book example, which is Zn zinc. Okay, wait a minute, like Here the overall reaction is zinc when add with sulfuric acid we gives the zinc sulfate and hydrogen blah blah blah. So instead of using this we simply denote zinc plus H2SO4 for sulfuric acid, ZnSO4 for zinc sulfate and H2 for hydrogen. So now it is very easy, like anyone can understand. So zinc H2SO4 get zinc sulfate SO4 plus hydrogen. So this is our question. Now it's time for balancing. Okay, the first step is balance the higher element. Higher element is now here oxygen. Is that oxygen balanced in both cases? Yes, oxygen is balanced in both these cases. So we can see this oxygen is balanced. And second thing is the lower, which is the hydrogen. Is that hydrogen is balanced? Yes, hydrogen is balanced. And the lower from zinc is zinc balance. Yes, zinc is balanced. So basically overall equation, overall reaction is balanced. What? So first from high or low, whenever you choice. For low, then low upper, then upper, that your choice. For second, the low and the low, or basically vice versa, you can say. I use the second example. Yeah, it was good. And the second case is very clear. So when the iron add with the water, what we see? The dust. Okay, like a Fe3O4 and hydrogen. Now for the lower than upper. Okay, so highest part is oxygen. Okay, or lowest. So first we move from the higher to lower part. Let's see from high part what happened, and then low part. Let's clear the doubt. What doubt came in my mind? Like if we say that from we balance from high to a high element, then the low. What if we balance from lower to upper? Let's see what happened. For higher, the oxygen is 4. Here is 1. Multiply by 4. Now the step is become a high, this 4 H2O Fe3O4 plus H2. So oxygen balance, hydrogen now become 8. Here hydrogen 6, so 2 8 hydrogen balance. And for this iron is balanced by 1 by 3. Lower. Okay, now for if we create for lower part, yeah, this is the lower. Here is 3. So here we can see that the iron is multiplied by iron 3. We get 3 iron multiply because of the matching for both cases. And H2O is simple, gives FeO3O4 plus H2. And for here is hydrogen is 2, here is hydrogen is 2. Okay, now for oxygen, his oxygen is 1 but oxygen is 4. Then multiply by hydrogen, this we can get the oxygen is 4. Now the hydrogen is 8, so hydrogen is 4 to the 8. So overall element is now. So both cases are same. So I hope you understand the concept of balancing again. So the step 1 for the higher to lower. Okay, so once again I explain the next topic. That is, oh, it is okay, clear. Okay. So basically the first step is check for the higher power. Higher power is oxygen, multiply by the part where the oxygen is here. So oxygen is 4, so multiply, first we multiply H2O by 4. So here we get the oxygen is 4 and here oxygen is 4, but hydrogen is now become 8, but here is hydrogen is 2. So next step we multiply hydrogen by 4. Now hydrogen become 8, so hydrogen become 4 to the 8, 4 to the 8, 4 4 4 4. Now the iron, which is 3 1 but is 3, so higher is 3. For making the same thing, the lower part also become 3, so multiply iron by 3, so Fe become 3, like, okay, so 4H2O and 4H2 Fe3. So overall become Fe3 plus this, we get this plus of H2. I hope you understand what I am saying, and I give you some example in the next question. You solve it for it. Okay. Just digest the overall what I am studying this. In next class we will definitely see the same, and if you understand, build your own question, your own. Okay, bye bye.